Hello students, welcome all of you. In this video, we will discuss a very important topic in waves, chapter 15, book 2 of class 11 physics, which is various modes of vibration in a closed and an open organ pipes, in part 3 of this chapter. But before doing it, we have to discuss organ pipes and types of organ pipes. There are some musical instruments like flute, clarinet, whistle, etc., in which sound is produced due to vibration of air columns. Organ pipes are sound producing cylindrical tubes in which sound is produced due to vibration of air column present inside it. Organ pipe सिलिंड्रिकल ट्यूब्स है जिनके अंदर प्रेजेंट उपस्थित एयर कॉलम्स में वाइब्रेशन के कारण साउंड प्रोड्यूस्ड होता है. ऑर्गन पाइप्स आर ऑफ टू टाइप्स. नंबर 1, क्लोज्ड ऑर्गन पाइप. द ऑर्गन पाइप whose one end is open while the other end is closed is called a closed organ pipe. वैसा ऑर्गन पाइप जिसका एक इंड खुला होता है, ओपन होता है, एंड अदर इंड क्लोज्ड होता है, उसे क्लोज्ड ऑर्गन पाइप कहा जाता है. एंड नंबर 2, ओपन ऑर्गन पाइप. That organ pipe whose both ends are open is called an open organ pipe. वैसा organ pipe जिसका दोनों ends ओपन होता है, खुला होता है, उसे ओपन ऑर्गन पाइप कहा जाता है. Now coming to the point, we have to discuss various modes of vibration in a closed organ pipe first, and then after in an open organ pipe. When the open end of a closed organ pipe is blown, then there is vibration of air column present inside the organ pipe, and a longitudinal wave travels along the closed end of the organ pipe, where the wave is reflected back, and due to superposition of two longitudinal waves, that is incident longitudinal wave and the reflected longitudinal wave inside a closed organ pipe, a stationary waveform is produced in a closed organ pipe. जब किसी क्लोज्ड ऑर्गन पाइप के ओपन एंड को फूंका जाता है तो इसके अंदर प्रेजेंट एयर कॉलम में वाइब्रेशन होता है एंड एक लॉन्गिट्यूडनल वेव क्लोज्ड ऑर्गन पाइप के ओपन इंड से क्लोज्ड इंड की ओर ट्रेवल करता है, जो कि क्लोज्ड इंड जो कि एक फिक्स्ड बाउंड्री के जैसा है। तो क्लोज्ड इंड से रिफ्लेक्ट होकर लॉन्गिट्यूडनल वेव बैक हो जाता है और जब क्लोज्ड ऑर्गन पाइप के अंदर इंसिडेंट वेव फॉर्म, दैट इज इंसिडेंट वेव, इंसिडेंट प्रोग्रेसिव वेव एंड और इंसिडेंट लॉन्गिट्यूडनल वेव एंड रिफ्लेक्टेड लॉन्गिट्यूडनल वेव एक दूसरे से सुपरपोज्ड होते हैं, एक दूसरे से मिलते हैं। तो इस प्रकार स्टेशनरी वेव फॉर्म का फॉर्मेशन होता है किसी क्लोज्ड ऑर्गन पाइप के अंदर। इन द सिंपलेस्ट मोड ऑफ वाइब्रेशन इन ए क्लोज्ड ऑर्गन पाइप, since open end is free, where the medium particles, that is air, has freedom to vibrate, so antinode is formed, that is rarefaction occurs at the open end of a closed organ pipe, while the other end which is closed, while the other end of the organ pipe which is closed, there is no freedom of vibration for the medium particles, that is air molecules, and hence compression occurs at the closed end of a closed organ pipe. Therefore, node is formed at the closed end, while antinode is formed at the open end in the simplest mode of vibration of a closed organ pipe. तो किसी क्लोज्ड ऑर्गन पाइप के सिंपलेस्ट मोड ऑफ वाइब्रेशन में, मोड मीन्स मेथड, वे, तरीका, तो सबसे सिंपलेस्ट मोड वाइब्रेशन का क्लोज्ड ऑर्गन पाइप में, क्लोज्ड ऑर्गन पाइप के ओपन एंड पर एंटी नोड का फॉर्मेशन होता है, क्योंकि क्लोज्ड ऑर्गन पाइप के ओपन एंड पर एयर के वाइब्रेशन, दैट इज मीडियम पार्टिकल्स, एयर मॉलिक्यूल्स के वाइब्रेशन का फ्रीडम है, इसलिए एंटी नोड का फॉर्मेशन फ्री एंड पर होगा, जबकि अदर एंड विच इज क्लोज्ड, अदर एंड ऑफ द ऑर्गन पाइप विच इज क्लोज्ड, एट विच देयर इज नो फ्रीडम ऑफ वाइब्रेशन ऑफ द मीडियम पार्टिकल्स और एयर मॉलिक्यूल्स at the closed end, so compression occurs and nodes is formed at the closed end of the organ pipe. A node is that position where the medium particles are in rest, while the antinode is the position where the medium particles are far apart, that is freedom of vibration at the freedom of vibration of the medium particle at the open end of the tube. So in the simplest mode of vibration, we have node at the node is formed at the closed end of a closed organ pipe, while antinode is formed at the open end of the organ pipe. So length of the tube in the simplest mode of vibration is lambda 1 by 4. Suppose lambda 1 is the wavelength of the wave inside the tube, that is inside the closed organ pipe in the simplest mode. So length of the tube is lambda 1 by 4, because we know that the distance between a node and an antinode is lambda by 4, that is quarter of the wavelength. So in the simplest mode, write down in the simplest mode of vibration in a closed organ pipe, length of the tube L equals to lambda 1 by 4, and lambda 1 by 4 is the distance between a node capital N at the which is formed at the closed end and antinode which is formed at the open end of a closed organ pipe. Therefore, lambda 1, that is wavelength of the wave produced inside the organ pipe, which is a stationary wave formed due to superposition of incident longitudinal wave and reflected longitudinal wave. A stationary waveform is produced. So, wavelength of the waveform produced in a closed organ pipe in the simplest mode is lambda 1 is equal to 4L. Therefore, the fundamental frequency or first harmonic, fundamental frequency is also called first harmonic. So, fundamental frequency of the simplest mode is N1, and we know the relation between frequency, speed of sound and wavelength of the wave, sound wave is given by N1 is equal to V upon lambda 1 equals to V upon lambda 1 is 4L. So, suppose it is equation number 1. This is the expression for the fundamental frequency, which is also called first harmonic in the simplest mode of vibration in a closed organ pipe, which is N1, which is the fundamental frequency or first harmonic. Fundamental frequency or first harmonic produced inside the simplest mode of vibration in a closed organ pipe, and it is fundamental frequency is V upon 4L. We have substituted lambda 1 for 4L in place of lambda 1, since we have obtained lambda 1 is equal to 4L from the length of the tube in the simplest mode of the vibration. Lambda 1 is equal to 4L. So, using the formula of frequency, N1 is equal to V upon lambda 1, where V is the speed of sound in the closed organ pipe, and lambda 1 is the wavelength of the simplest mode or the fundamental mode of vibration. So, it is N1 is equal to V upon 4L. lambda 1 के जगह पर 4L रिप्लेस किया गया. सपोज इट इज इक्वेशन नंबर 1. सो फंडामेंटल फ्रीक्वेंसी इज in a closed organ pipe is N1 is equal to V upon 4L. L is the length of the tube, V is the speed of sound, sound wave in the tube. Now, in second mode of vibration, in a closed organ pipe, node is formed, two nodes are formed inside the tube, while two antinodes are also formed. Therefore, length of the tube in the second mode of vibration in a closed organ pipe is L equals to 3 lambda 2 upon 4, where lambda 2 is the wavelength of the wave produced inside the tube in the second mode of vibration. Distance between two nodes is lambda by 2. So, lambda by 2 can be written as 2 lambda by 4, and distance between a node and an antinode is lambda by 4. So, distance between two nodes formed in the second mode of vibration inside a closed organ pipe is lambda 2 by 2, that is we can write it lambda 2 by 2 as 2 lambda 2 by 4. and plus distance between a node in the middle, node formed in the middle, and second node formed in the middle. First node is formed at the fixed end, that is closed end of the closed organ pipe. So distance between the node formed in the middle and antinode formed at the open end of a closed organ pipe is again lambda 2 by 4. So total length of the tube is 2 lambda 2 by 4, distance between two nodes, and distance between the node in the middle and antinode at the free end is lambda 2 by 4. So total length of the tube is 2 lambda by 4 plus lambda by 4, lambda 2 by 4, that is 3 lambda 2 by 4. So in the second mode of vibration inside a closed organ pipe, length of the tube L equals to 3 lambda 2 upon 4. Therefore, lambda 2 equals to 4L upon 3. And now second harmonic or first overtone, second harmonic, second frequency produced in the second mode of vibration inside a closed organ pipe is called second harmonic N2 or first overtone. Second harmonic is first overtone. So second harmonic N2 or first overtone is N2 is equal to V upon lambda 2, that is V upon 4L upon 3, that is 3 into 3 न्यूमरेटर में चला जाएगा, V upon 4L upon 3, 3 will be multiplied in the numerator, so it is 3V upon 4L, and V upon 4L in equation 1 is equal to fundamental frequency or first harmonic. So it is 3N1. It is 3N1. Suppose it is equation number 2. So in the second mode of vibration in a closed organ pipe, second harmonic N2 or first overtone is equal to 3 times the fundamental frequency or first harmonic. That is, second harmonic is odd multiple of the fundamental frequency or first harmonic N1. Now we have to discuss the third mode of vibration inside a closed organ pipe. In the third mode of vibration in a closed organ pipe, there are 3 nodes formed inside the tube, while also 3 antinodes are formed. Therefore, length of the tube is 5 lambda 3 by 4, because distance between two nodes is lambda 3 by 2, which can be written as 2 lambda 3 upon 4, and distance between other two nodes is also lambda 3 by 2, which can also be written as 2 lambda 3 by 4. So 2 lambda 3 by 4 plus 2 lambda 3 by 4, that is 4 lambda 3 by 4, and distance between antinode formed at the open end of a closed organ pipe and the nearest node is lambda 3 by 4. So 4 lambda 3 by 4 plus lambda 3 by 4 is 5 lambda 3 by 4, where lambda 3 is the wavelength of the wave produced inside the closed organ pipe in the third mode of vibration. So length of the tube in this case, that is in the third mode of vibration, is L equals to 5 lambda 3 upon 4. Therefore, lambda 3 equals to 4 L upon 5, and hence third harmonics N3, third harmonic or second overtone Number of overtone is 1, smaller than the harmonic produced inside the organ pipe. So N3 equals to, N3 is the third harmonic, and second overtone is N3 is equal to V by lambda 3, using the relation between speed of sound, wavelength and frequency, that is V is equal to N lambda. Therefore N3 is equal to V by lambda 3, and it is V upon lambda 3 is 4L upon 5, and it can be written as 5 multiplied by V upon 4L. 5 न्यूमरेटर में चला जाएगा, 5 will be multiplied in the numerator, so it is N3 is equal to, that is third harmonic produced in the third mode of vibration in a closed organ pipe, और second overtone is N3. जो थर्ड फ्रीक्वेंसी प्रोड्यूस होगा थर्ड मोड ऑफ वाइब्रेशन में, उसको N3 सिंबल से डिनोट किया गया है, जिसे थर्ड हार्मोनिक कहा जाता है, एंड सेकेंड ओवरटोन. सो N3 इज इक्वल टू V by lambda 3, and lambda 3 we have obtained 4L by 5, so it is V upon 4L by, N3 is equal to V upon 4L by 5, that is 5 multiplied by V by 4L. Therefore N3 equals to 5 into V by 4L is N1 fundamental frequency or first harmonic from equation number 1. So N3 is equal to 5 N1, and it is equation number 3. From equations 1, 2 and 3, it is clear that the harmonics or frequencies produced in a closed organ pipe, that is in the different modes of vibration, in the various modes of vibration in a closed organ pipes are odd multiple of the fundamental frequency or the first harmonic N1. Since N2 is equal to 3 N1, N3 is equal to 5 into N1. So the ratio of different harmonics or various harmonics produced in a closed organ pipe, in closed organ pipes are N1 is to N1 ratio N2 ratio N3 equals to 1 ratio 3 ratio 5. That is, only odd harmonics are produced in different modes of or various modes of vibration in a closed organ pipe. जैसा कि हम लोगों ने किसी क्लोज्ड ऑर्गन पाइप के डिफरेंट मोड्स ऑफ वाइब्रेशन में यह देखा कि किसी क्लोज्ड ऑर्गन पाइप में केवल ऑड हार्मोनिक्स ही प्रोड्यूस्ड होते हैं, जिसके कारण किसी क्लोज्ड ऑर्गन पाइप से प्रोड्यूस्ड होने वाला साउंड मेलोडियस नहीं होता है. Since harmonics produced in different modes of vibration of a closed organ pipe are only odd harmonics, therefore sound produced by a closed organ pipe is not melodious. Now we have to discuss various modes of vibration in an open organ pipe. An open organ pipe is one whose both ends are open. ओपन ऑर्गन पाइप वह होता है जिसका दोनों एंड्स खुला होता है, ओपन होता है. When we blow air at one end, that is at the one open end of an open organ pipe, a longitudinal wave travels along the second open end of that open organ pipe and through the pipe, and the other open end works as an open boundary which reflects back that longitudinal wave in the opposite direction, that is towards the first end of the open organ pipe, and due to superposition of two longitudinal waves or two longitudinal progressive waves in the opposite directions, a stationary wave is formed inside inside an open organ pipe. जब किसी ओपन ऑर्गन पाइप के एक एंड को फूंका जाता है तो उसके अंदर एयर कॉलम में वाइब्रेशन होता है, और एयर कॉलम में वाइब्रेशन के कारण, ओपन ऑर्गन पाइप के अंदर एयर कॉलम में वाइब्रेशन के कारण एक लॉन्गिट्यूडनल वेव ट्रेवल करता है ओपन ऑर्गन पाइप के दूसरे ओपन एंड के टुवार्ड्स पाइप से होकर, दैट इज ओपन ऑर्गन पाइप से होकर, जहां सेकेंड ओपन एंड ओपन ऑर्गन पाइप का ओपन बाउंड्री की तरह बिहेव करता है, जो उस लॉन्गिट्यूडनल वेव को रिटर्न कर देता है अपोजिट डायरेक्शन में ओपन ऑर्गन पाइप के फर्स्ट एंड के लॉन्ग के टुवार्ड्स, एंड टू लॉन्गिट्यूडनल वेव्स जो कि अपोजिट डायरेक्शंस में इस प्रकार ट्रेवल करते हैं, उनके सुपरपोजिशन से ओपन ऑर्गन पाइप के अंदर स्टेशनरी वेव का फॉर्मेशन होता है, जिसे देखा जा सकता है फिगर 2A सिंपलेस्ट मोड ऑफ वाइब्रेशन में, सेकेंड मोड ऑफ वाइब्रेशन में, फिगर 2B में, एंड इन लास्ट फिगर 2C में. In the simplest mode of vibration of an open organ pipe, two antinodes are formed at two open ends of the open organ pipe, while in the middle node is formed. So in the simplest mode of vibration in an open organ pipe, length of the tube is lambda 1 dash upon 2, where lambda 1 dash is the wavelength of the wave produced inside the open organ pipe in first mode of vibration. We know that distance between antinode and node, distance between an antinode and a node is lambda by 4, and again between a node and antinode is lambda by 4. So here in place of lambda we can write here lambda 1 dash. So lambda 1 dash by 4, distance between the upper end of the open organ pipe where antinode is formed, and in the middle where node is formed. So distance between antinode and node is lambda 1 dash by 4, and again distance between node in the middle and antinode at the lower end in this figure, that is the first open end of the open organ pipe, is again lambda 1 dash by 4. So total length of the tube is, in this case, is lambda 1 dash by 4 plus lambda 1 dash by 4, that is lambda 1 dash upon 2. So in the simplest mode of vibration in an open organ pipe, write down in the simplest mode of vibration inside an open organ pipe, we have length of the tube L equals to lambda 1 dash upon 2. Therefore lambda 1 dash is the wavelength of the wave formed inside the open organ pipe in the simplest mode is lambda 1 dash is equal to 2L. Now first harmonic or fundamental frequency is given by N1 dash, that is first harmonic produced inside an open organ pipe in the simplest mode of vibration is N1 dash is equal to V is the velocity of sound wave inside the tube. So N1 dash is equal to V upon lambda 1 dash, and lambda 1 dash we have obtained already, in this case 2L. So N1 dash is equal to V upon 2L. Suppose it is equation number 4. Equations 1, 2 and 3 we have obtained already in various modes of vibration in a closed organ pipe. So it is equation number 4, that is expression for fundamental frequency or first harmonic in an open organ pipe is N1 dash is equal to V upon 2L. In place of lambda 1 dash we have replaced 2L. In place of lambda 1 dash we have replaced 2L, which we have already obtained in this case. Now in the second mode of vibration in an open organ pipe, two nodes are formed inside an open organ pipe while three antinodes are formed. So length of the tube in this case, that is in the second mode of vibration, is lambda 2 dash. Distance between antinode and node is lambda 2 dash by 4. Again distance between node and antinode at the first end, near the first open end of the tube is again lambda 2 dash by 4. So lambda 2 dash by 4 plus lambda 2 dash by 4 is lambda 2 dash by 2, and distance between two nodes inside the open organ pipe is lambda 2 dash by 2. So lambda 2 dash by 2 plus lambda 2 dash by 2 is lambda 2 dash. So length of the tube length of the tube in the case of second mode of vibration, in which two nodes and three antinodes, two nodes and three antinodes are formed, is L is equal to lambda 2 dash. Antinode is the position of maximum displacement, while nodes at nodes medium particles, that is air molecules inside the tube, are in rest. That is at the position of nodes compressions occur, while at the antinode rarefaction occurs. So in the second mode of vibration, write down, in the second mode of vibration inside an open organ pipe, we have length of the tube L equals to, total length of the tube is lambda 2 dash, L is equal to lambda 2 dash. Therefore lambda 2 dash can be written as is equal to L. Lambda 2 dash is equal to L. L is equal to lambda 2 dash, that is lambda 2 dash is equal to L. Therefore second harmonic, that is second frequency produced in an open organ pipe in the second mode of vibration is N2 dash, which is known as second harmonic or first overtone, and it is second harmonic produced inside an open organ pipe in the second mode of vibration is second harmonic or the first overtone is N2 dash equals to V by lambda 2 dash equals to V upon lambda 2 dash is equal to L, and we can write it as 2 multiplied by V upon 2L, multiplying numerator and denominator by 2, so that in place of V by 2L we can write N1 dash. तो न्यूमरेटर एंड डिनोमिनेटर में 2 से मल्टीप्लाई किया गया है. इसका कारण यह है कि V by 2L के जगह N1 डैश वी कैन राइट लिखा जा सकता है, जो कि इक्वेशन 4 में हमने ऑब्टेन किया है. ओपन ऑर्गन पाइप का फंडामेंटल फ्रीक्वेंसी और फर्स्ट हार्मोनिक N1 डैश इज इक्वल टू V by 2L. सो वी कैन राइट हेयर 2 multiplied by N1 dash. N1 dash is the fundamental frequency of the simplest mode or fundamental mode of vibration in an open organ pipe. So N2 dash is now even multiple, 2 into N1 dash. So say it is equation number 5, N2 dash, that is second harmonic produced in the second mode of vibration in an open organ pipe, or which is also known as first overtone, is N2 dash equals to 2 into N1, that is 2 times, that is second harmonic in an open organ pipe is 2 times the fundamental frequency, or 2 times the first harmonic produced in an open organ pipe, or 2 times the fundamental frequency in an open organ pipe. Second harmonic is N2 dash is equal to 2 N1 dash. Now, in the third mode of vibration inside an open organ pipe, which is shown in figure 2C, there are 3 nodes inside, 3 nodes formed inside the open organ pipe, while 4 empty nodes, total 4 empty nodes are formed. So 4 empty nodes and 3 nodes are formed in the third mode of vibration in an open organ pipe. So length of the tube in this case is 3 lambda 3 dash 3 by 2, 3 into lambda 3 dash by 2. As we know, distance between 2 nodes, either 2 nodes or 2 empty nodes is lambda by 2, while distance between a node and an empty node is lambda by 4. So total distance in case of 3 empty nodes, in case of 3 nodes and 4 empty nodes formed inside an open organ pipe, total length of the loop or total length of the tube, total length of the loops formed inside an open organ pipe, or total length of the tube is L is equal to 3 lambda 3 dash upon 2, where lambda 3 dash is the wavelength of the sound wave produced inside the third mode of vibration in the open organ pipe. So in the third mode of vibration in an open organ pipe inside an open organ pipe, we have total length of the loops formed inside the open organ pipe, or total length of the tube is L equals to 3 lambda 3 dash upon 2. Therefore, we can obtain lambda 3 dash, that is wavelength of the wave formed inside the open organ pipe in the third mode of vibration is lambda 3 dash is equal to 2L upon 3. So write down lambda 3 dash, L is equal to 3 lambda 3 dash upon 2. Therefore, lambda 3 dash equals to 2L upon 3. Hence, third harmonic, that is और सेकेंड ओवरटोन. तो ओपन ऑर्गन पाइप के थर्ड मोड ऑफ वाइब्रेशन में जो थर्ड फ्रीक्वेंसी ऑब्टेन होगा उसे थर्ड हार्मोनिक कहा जाता है और सेकेंड ओवरटोन. सो third harmonic N3 dash produced, third harmonic produced in an open organ pipe in the third mode of vibration is N3 dash is equal to V upon lambda 3 dash and is equal to V upon lambda 3 dash is replaced by 2L upon 3 which we have already obtained. lambda 3 dash के जगह 2L upon 3 replace किया जाए. So we have now N3 dash, that is third harmonics produced in an open organ pipe, or second overtone is N3 dash is equal to V upon 2L by 3, and it is now 3 multiplied by V upon 2L, and V upon 2L is the fundamental frequency N1 dash which we have already obtained in equation number 4. So we can write here N3 dash, that is the third harmonic produced in an open organ pipe in the third mode of vibration, or second overtone N3 dash is equal to 3 into V upon 2L, 3 multiplied by V upon 2L, and V upon 2L is N1 dash using equation number 4, which is the fundamental frequency or first harmonic produced in the first mode of vibration inside an open organ pipe. So N3 dash is equal to 3 N1 dash, which is, that is third harmonics or second overtone inside an open organ pipe is 3 times the fundamental frequency inside an open organ pipe, and it is clear that N3 dash is 3 times the fundamental frequency, and it is odd multiple, that is third harmonic produced in an open organ pipe is odd multiple of the fundamental frequency, while we have obtained N2 dash, that is second harmonic produced in the second mode of vibration in an open organ pipe is N2 dash is equal to 2 times the fundamental frequency, that is 2 into N1 dash. Hence it is clear that in an open organ pipe the harmonics produced are even and odd multiple of fundamental frequencies. Therefore sound produced in an open organ pipe is melodious. चूँकि किसी और ओपन ऑर्गन पाइप में प्रोड्यूस होने वाले फ्रीक्वेंसीज फंडामेंटल फ्रीक्वेंसीज N1 डैश के इवन मल्टीपुल एंड ऑड मल्टीपुल दोनों होते हैं, इसलिए ओपन ऑर्गन पाइप में प्रोड्यूस्ड होने वाला साउंड मेलोडियस होता है, जबकि क्लोज्ड ऑर्गन पाइप में प्रोड्यूस होने वाला हार्मोनिक्स केवल ऑड हार्मोनिक्स होने के कारण मेलोडियस नहीं होता है. सो द फाइनल रिजल्ट इज N3 डैश इज इक्वल टू 3 multiplied by N1 dash, that is third harmonics produced in an open organ pipe is 3 times the fundamental frequency or first harmonic, and it is the final expression, equation number 6. So it is clear that the ratio of different frequencies produced in different modes of vibration, in various modes of vibration in an open organ pipe is N1 dash ratio N2 dash ratio N3 dash equals to 1 ratio 2 ratio 3, that is even and odd harmonics, that is all harmonics are present inside in various modes of vibration in an open organ pipe. Now this video is completed. यदि यह वीडियो आप सभी को पसंद आया हो तो इस वीडियो को अधिक से अधिक लाइक करें, दूसरे से शेयर भी करें अधिक से अधिक, तथा मेरे YouTube चैनल फिजिक्स क्वांटम क्लासेस को अधिक से अधिक सब्सक्राइब करें. थैंक्स ऑल ऑफ यू फॉर वाचिंग माय YouTube चैनल फिजिक्स क्वांटम क्लासेस.